All right, it's been a minute, so we're back. All right, so now we're going to be talking today about Qbert's, I think it's 369 days of um, note cards that most of them have TTM notation, maybe half of them. But we're going to be correcting Qbert's notation. He's got some design flaws, some mathematic flaws. So today's lecture is about what a function is and basically any scratch wave, which is a TTM wave, should be an actual function, meaning something that you can actually do in nature. And if it's not, then it's going to be a digital thing, like track skipping with the CD, or reverse toggles using a CDJ reverse button, right? But it doesn't sound like scratching. All right, so let's talk about the change of direction first. You see right here at the top how this it's like a pyramid where the scratch is going forward, and then he has two kind of swipes in there, and then it changes direction instantaneously. That's not possible in nature. That's actually what we would call a digital reverse switch toggle. If you look at your periodic matrix of scratches chart, you can refer to it. You can find on the right side of it, in the north east corner of it, you'll see digital reverse switch toggles. So this is when the record is playing forward, and then you hit the reverse button, and then it plays backwards automatically. And it doesn't sound like scratching. We have a whole lecture on that. You can refer to that. All right. And for those that don't know, TTM is basically the movement of the record's cue point over time. So if you think about this as the cue point, and this is time, time is the x-axis, and the degrees of the cue point on the record is the y-axis, then over time you can see time is passing, and then the position of the cue point is changing over time, right? So that's basically what TTM is. The position of the cue point is changing over time. Now, with this one, we're going to talk about functions today, because we've already talked about, the fact that the change of direction should always have a little bit of a curve. It should never be a sharp point when you're changing directions. Just like if you ever did sports here in the U.S., we have a thing called suicides, where you run to the wall and you turn around and run the other direction, or you run to a line and run to the other direction, and you have to stop and slow down to change directions. So anytime you're changing directions on a turntable, it should always be kind of curved at the top, because you have to actually slow down to change directions. Only a like a CDJ can just change directions automatically, and if you change directions automatically like this, it's not going to sound like scratching. And a lot of people say, why be a stickler? Well, it's important to be a stickler because this is math. TTM is a mathematic language, really the only mathematic language out there, mathematic musical language. And yeah, so let's go into this a little bit more. All right. So we're going to talk about what a function is today. So a function is basically a graph like this. Where I'm going to show you right here. This is a simple explanation of what a function is. A function means it's a graph that can be done in nature, right? So like this could be the stock market going up and down. This could be a bird flying up and down. This could be um, you know, the cue point of the record going up and moving back and forth. So this is oscillation. So it's going up and down and up. And anything that's a real function that can actually be done in nature, you can draw a line through it that's parallel with the y-axis. This is the y-axis. This is the x-axis. You can draw a line through it, and the line is only going to go through it once. So you see this is a function. But this one right here is not a function, because there's 2 points that are the same on the x-axis. So the x-axis should never have 2 points that are the same, right? Because the x-axis is time, right? You should never be in 2 places at the same time. That's impossible, right? Unless you have 2 players playing the same sound at the same time. But that's not that's not what this is showing. This is showing that this event happens twice at the same time, right? Same with this one. This shows that the event happens. This circle right here shows that the event is happening right here and right here. So that's not a function. It's a cool design, but it's not a mathematic function. It has a mathematic formula. Everything can have a formula, but it's not a function, right? So all scratches must be functions, right? So with Qbert's example right here, we can see that, yeah. So with, let's see, okay, yeah. So with Qbert's example right here, we can see that it's going forward, and then it goes. This is supposed to be representing tapping the record twice, right? So you see it's going forward, and then it's going backwards, and then it's going forwards again. But now it's starting to curve backwards in time, because remember, time is the x-axis. Where I'm moving with the mouse, that's time, the x-axis. So it's gone backwards in time. So if you draw a line through this, and actually the little Facebook thing right here actually has its own line through it, you can actually see there's like a little line right here, that it's not a function. So this is an incorrect way of drawing a tear or a tap. So here's some other ways to draw a tear. It's either going to be like going forward and then it stops and it's a pause, and then you let it go and it plays again, right? Or it could be more of a softer type of a tap, like, if you're tapping with your fingers or swipes. When you swipe the record, you see there's a lot more softer way. So it's going forward, and then it stops, and then it goes forward again, and then backwards a little bit, and forward again. But you can always draw a straight line through it, and there's never going to be 2 points on the straight line, on the x-axis. So here's some other types of taps. You can see this is going forward, and it's tapping for a longer time. Like if you're beat juggling, this is what people do when they're beat juggling. They're letting the record play, and then they hold it for a 16th note and let it play, right? And this is a reverse version of that, where they're rewinding it, and then they let it play for a 16th note, and then, that type of a thing. And see, the swipes can be much quicker, but you see it's never going to be curved like this, right? And so there's bubble taps. So these are much more softer, kind of bubbly ways to tap. So the lines should always be curved, and they can be, kind of straight like this. They don't have to always be super curved. Like if it's just a general tap where you're holding it for a second and then letting go, right? But you can see with this Qbert example, this is like an actual circle. And this is more of the graphic designer who did this. Maybe doesn't know how to use Illustrator. They're probably not using Illustrator. Maybe they are, but you kind of have to use Illustrator if you're going to be drawing complex stuff like this. Or just you can draw freehand too with any graphic tool. But this is the designer's mistake. And now we're going to go to another one. I believe there's another one that does the same thing. And it's also important to note too that you can't have a vertical line, right? That's a scratch, right? Because in this example, we can see a vertical line has a specific meaning. A vertical line means you're skipping tracks. Like let's say this is track 1, and then you can play into track 2. If you're just skipping automatically to track 2, that's a vertical line. So that's track skipping if you have a vertical line. You're just skipping from one point of the sample to another. So like let's say this is the beginning of ah, and then let's say this is the starting of fresh right here. Ah starts right here and fresh starts right here. So remember the y-axis is degrees. So if fresh ah is right there, and then fresh starts right here, you could track skip to fresh and be like, okay, I don't want to use ah, I'm going to use fresh, right? So that's track skipping, right? But so you're jumping in time, but you can't do that with a normal, unless you're using a cue point button. You can jump in time like that. So that's what this would show, either track skipping or using a cue point button to change the cue point, like people do now with the modern mixers, But yeah, so let's go to this next one. All right. Whoops. Oh yeah, yeah. Shout out to these cats in Spain. They got the TTM T-shirts. Let's see. All right, here's another one. So this one's a similar type of a thing where we see a function can only have a vertical line going through it once. This one's not a function. This one's not a function, and this is not a function. These are too close together. Anytime you're representing like military cuts or stabbing or cuts, if you have them too close together where you don't have enough time to bring the button back, this really would represent like you using a button on a cue point button on the on modern mixers. But that's not what he's trying to say here. He's trying to say that this is going, like fresh, fret, 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 like that. And he's trying to say that the person's going fret, fret really fast. But see, you have to have time to pull the record back. And in this example, I put this black line here to show that there's the record is in two places at the same time, which is impossible. Now, this is possible if you're using the buttons on your mixer, if it's a sampler, so samplers can break time, but the human body can't break time. And in his example, he's not using a sampler, the sampler that's in a mixer or in a computer. He's just scratching. So this is improper TTM notation because it's showing 2 points that are happening at the same time. So you see how this is not a function. If you have a point here and a point here and a point here and a point here, there should always be some type of slope to the line, right? They should always have some type of slope. Even with this line right here, this line right here, it almost seems vertical, but there's a little bit of a slope to it. Same with this one right here. It almost seems vertical, but there's a little bit of a slope to it. So as long as there's a little bit of a slope to it, then it's fine. But if it's a vertically straight up line that's exactly straight up, then that's off. That's not correct, right? So there should always be a slope to a line. It should never be a vertical line, all right? So let's go back. All right, so this is improper notation because you can draw a vertical line through it. So that's just a simple rule of thumb. You know that it's impossible to do in nature if you can draw a vertical line through it, and it goes through 2 points or 2 or more points within the notation. All right, so we're going to show one more example, a newer example that he just did. I believe, let's see, I think I have it saved over here. Yeah, here we go. Let me bring this up. So yeah, this is a great example right here where you see that, so this is like a little rub going to, and remember this should be rounded at the top because you can't change directions instantaneously. Just like UFOs, they say that, like an airplane can't fly one direction and then fly the other direction instantaneously. Only like UFOs and things that, don't are strange in the sky can do something like that. Like technology we don't have that defies the laws of physics, right? So we haven't proven that, but people have seen UFOs, so-called UFOs, or whatever image in the sky that can just change direction without having to slow down and speed up. But this is impossible in scratching. And so once again, right here, if we draw a vertical line through this swipe here, this is like a swipe. It's going forward, and they pause the record for a second, and then they go backwards and swipe it again. So you can see I'm going to draw a vertical line through it, and you can see it's touching at this point and it's touching at this point. So this is not a function because it's, up into here it's a function, and then it's going here, but then by the time it goes backwards in time, you can't scratch backwards in time like that. Time is always moving forward for us. Even though a record, you can reverse it and stuff like that, time is still moving forward for us. So even if you're reversing the record, like here, the record is being reversed, time is still moving forward. All right. So yeah, that's basically it. So you can, the easy way to test if something is a function is just to put a vertical line through it. So if you're drawing some TTM stuff, you can test it out by just drawing a vertical line and to know if your notation is off, right? So we can see that Qbert's notation is off. So we're going to be going through and auditing all the notation stuff that's out there from all TTM artists and TTM composers and designers and stuff. And once again, shout out to Qbert. This is scrutiny is not the same as like a diss. This is not dissing. This is just correcting a student. So I consider all TTM composers out there students of my discipline and methodology, and this is just correcting. Just like if you're a math teacher, you can correct multiplication or correct division. So this is basically kind of trigonometry. This is also kind of calculus. Trigonometry is when you're dealing with waves, and calculus is when you start cutting up waves and having more complex equations, more complex stuff happening. So so we can see right here, this is basically a lecture on what is a functions, and that's basic trigonometry. So trigonometry 101. This will help you on your SATs if you're here in America, ACTs. If you're in another country, whatever your standardized tests for high school or secondary school or college or universities, they're going to have this on your test about what is a function. And now you know what a function is. Now you're going to be able to know that when if a line can go through it, that's not a function, right? And then on a similar note with this, if a line can go through this, it's not a function. And we're going to do the line test right now with this one just so you can see it like this. Whoops. Like you can see this line going through it. See how the line is at, this is a point here, and the line goes, this line right here I'm talking about, this vertical line, it goes through it right, it touches at the same point. So that's not a function. So that's basically improper notation. It looks cool. It looks like an arrowhead or something like that. I think it's cool, design-wise. It looks cool, but it does not follow this basic concept of what a function is. So, lastly, we're just going to read off what is a function, and here's some more examples of what a function is and what's not a function. So, like this looks cool. Like if you make some TTM and you're like, oh look, this is my scratch. But if you draw a scratch like this, that's not real. That's not a real scratch that could be done because look, it goes 1, 2, 3. It crosses the x-axis. It crosses this 3 times. It happens 3 times at the same time. Remember, the x-axis is time. The y-axis is the movement of the Q point over time. You could think about it as the Q point sticker. So the Q point sticker is at 0 degrees. That's your starting point, and now maybe it's at maybe 90 degrees at another point. So this is the Q point, where the Q point is over time. So you can have the Q point appear at the same place a lot of different times. But over time, it can only appear at one place each time, like this example, which is a real function. So the Q point is going up, it's going forward, and then it's pulling the record back. So this is going and starting. It's going reverse and then forward and then back. And notice how the curve is nice and curved at the top. Scratches should always be curved at the top. Tony's Scratchery has really good TTM handwriting where his scratches are always curved. A lot of people feel like, oh, I don't need to do curved scratches, but it's very important to curve these things at the top. And you can see this one. This is a function right here. See, because you can draw one line through it, and this is just the record reversing, it's being pulled backwards, right? So we can look at some more ones. See, that's what I was saying. This will be on a test in the future if you're, taking trigonometry. So it's like, is this a function? No. Because you can draw a vertical line through it and it hits it at 2 points. Is this a function? Yes. See, it looks like a scratch. It looks like a baby scratch, forward, back. Is this a function? No, it doesn't look like a scratch, right? See, it's not a function. Same with this one. This triangle thing here is not a function, right? So, and you can apply that to all types of stuff, like, so this is a function, this is a function, this is a function, because if you draw a vertical line through it, it's a function. Now, these are interesting because these are called asymptotes. Let me click back. This is an asymptote where it almost gets vertical, but it never gets vertical, So like in that one example I was showing you, where it looks like it's almost vertical, but it's not. So as long as it's never vertical and never touches this x-axis, then it's called an asymptote, where it's almost vertical, but it's not. So that's like when you're doing a stab that's really, really fast, really, really high pitch. All right, so you see all these are functions. This is identifying a function, whereas this is not a function, and this is not a function, right? The vertical. So this is called the vertical line test. So that's basically what this lecture is about. It's the vertical line test. You can use the vertical line test to understand if your scratch is actually a function, right? You see the vertical line test works in this one. The record is just going forward, like or fresh, and this one is not. You can't just have a circle, right? You can't. That's not a. There's an equation for that, but it's not a function. It's not something that can happen in reality, right? All right, so that's basically it. All right, so yeah, thanks for tuning in. And updates. Yeah, we're about to drop the PMOS 100 1.5 version that has an actual sequencer in it now. That we added a step sequencer. We already had the AI kind of sequencer where it's kind of you're giving it kind of scratch prompts, and it'll just start kind of scratching and stuff with the prompts, given the scratches that you feed it, and it'll do a scratch on its own. But the sequencer section, you can actually control exactly how it's going to sound. We're adding, 4 different types of rests, like 16th note, eighth note, quarter note, whole note type of a thing. We'll add 30-second notes in the future, but for now we just added 16th notes. Yeah, so that's basically it. And then also remember we just bought Scratch videos on Facebook. So now we're just posting hardcore turntablist stuff, content all day, every day. So you can tune in to Scratch videos at Facebook. Yeah, and that's Scratch videos with a S, not the one that copied Scratch videos with the O. That's much more recent. But shout out to that guy too. Shout out to everybody that's part of turntablism. My only question with that guy is that he's not an actual DJ. The guy from Scratch Video, out of France, he's just kind of trying to make money off of turntablists and uploading everybody's videos. But we'll do a lecture on that in the future of kind of like culture vultures and people, trying to monetize turntablism and that aren't actually part of the culture, right? Because who knows, he could be a gear company that's backing him or something. Yeah. Also, and yeah, that's basically it. And yeah, as we can see here, this is a function. This is not a function. This is not a function, but this is a function. So these 2 top ones are functions. These 2 bottom ones are not functions because these bottom ones do not pass the vertical line test. All right, and that's it. And yeah, we'll be auditing all of Qbert's 369 days of scratches. Because I've noticed too that some of his notations seem to not be matching what the scratch that he's doing is. So we'll be analyzing those on a deeper level in the future. All right, peace.